Good afternoon. My name is Pierre Bilodeau. I'm the Industry Manager for Defense and Security at Esri Canada, and welcome to our webinar on turning drone imagery into timely intelligence. So today we're going to be presenting some of our drone image processing solutions to help you create products in support of your organizations or your current drone operations. Our focus will be on drone to map for desktop and our side scan cloud-based offering. We also have packages of these two products specifically tailored for your drone projects and imagery requirements that we call drone collections that we'll cover later on in the presentation. So let me introduce my colleague today. So joining me will be Geneviève Lavoie. She's our imagery solution specialist located in Ottawa, and Brian Lads, our technical solution specialist assisting the National Capital Region. So before we begin, let me go over some admin points. So we are recording this webinar. You'll get a link in an email after this event, and we'll ask you also to answer the survey at the end of the webinar. We're going to be taking questions at the end. We have a Q&A period scheduled later on around 12:45. So please use the Q&A panel throughout the presentation to ask your questions. You can ask all panelists. So on the agenda for today, I will give you a use case of how the Dutch engineers are using the drone for bridge reconnaissance. Then I'll give you a quick description of our imagery platform, how scalable it is, how integrated it is with the rest of the system. I'll cover the 4 products included in our photogrammetry portfolio. Then I'll pass it over to Geneviève to cover our drone imagery management with the image server. She will then describe drone to map and give you a demonstration of drone to map. And then Brian will then cover the side scan cloud-based software, including a demonstration. He will also describe the drone collection. Then I will provide a quick summary, and then we'll go into a Q&A period. So as I mentioned here, for a military use case, what I want to share with you today is how the Army engineers in the Netherlands are using the DJI drone data to create a 3D model of their bridge sites. And they do that within 30 minutes from landing their drone. So let me share my screen and open the story map. You can see here their list of requirements. So they wanted to create a 3D virtual reality environment. They wanted to use all the 2D, 3D GIS data available. They wanted to do this processing on site in a disconnected mode. They wanted to use the existing tool. They had already purchased drone to map. And more important, they wanted to do that within 30 minutes of landing their drone. So for their solution, all their 3 approaches all use drone to map to process the data captured by the drone, and also the Unreal Engine to provide this 3D environment so the user can walk through the scene and explore the site using the goggles, I should say. So drone to map is used by the Dutch engineers to generate 3D and 2D products. So the 3D products include a scene layer package, 3D meshes in different formats, and a last point cloud. And the 2D products include an ortho mosaic, a digital terrain model, a digital surface model, and contour lines, as you can see here in the example. And then what they do is they then use the Unreal gaming engine to create a virtual environment. So they generate a 3D model of the bridge site with realistic textures and animation effects, and you can see here with the goggles an example. And I want you also to know that Esri is currently developing an SDK, a software development kit, a plugin for the Unreal Engine, which will be ready by early 2022, early next year, which will allow developers and users to integrate ArcGIS web services and local data into the Unreal 3D and VR applications. So watch that, I think, later or early in the new year. So the engineers in the Netherlands, they use data from 3 separate UAVs to generate these bridge scenes that you see here with different flight plans, different image specifications, and a different number of images for each drone. And the 3D meshes and terrain become then the tabletop VR scene, and the user can then teleport himself and experience the 3D environment, as you can see here. So if I click on the results here, the final result is a realistic virtual reality scene of the site, rapidly produced, offline, within 30 minutes, with a high level of details for spatial awareness for planning purposes, which give them an immersive VR experience. We will share the story map link with you so you can view the details of the 3 solutions and later on your own. So I'm going to go back now to the presentation. So I just want to cover first our imagery platform. As you know, ArcGIS includes an integrated and scalable imagery platform that is capable of supporting all the imagery needs of your organization. So starting from the left there, once you have collected your raster imagery, your point cloud data sets from various sensors, either stored in the cloud or on-premise, you can then use our photogrammetric tools, and I'll describe them next. And you use those tools to process your data in 2D and 3D products that other users in your organization can then access using either desktop or web application. So our system can display updated imagery information in many applications. For example, decision makers can use story maps or dashboard to view this updated information. So with ArcGIS, you can transform your imagery quickly into meaningful and timely information for planning purposes and to support your commanders or your decision makers. And this is what we mean by ArcGIS as an integrated and scalable imagery platform. As I mentioned also, ArcGIS Pro is our premium desktop application for imagery processing and analytics, which is further improved when you add the imagery analyst extension. So ArcGIS Pro is your access point for publishing imagery to the server and then creating those imagery services for use in other web applications. So we use photogrammetry to process and make those drone images more accurate and more precise for use within your GIS. We have analytics that can be set to run at scale to extract features from imagery, from drone imagery, and do all types of advanced analysis like change detection, object classification, or patterns of use. So we have added many machine learning and deep learning workflows into the image analyst extension over the past few years to save you time. And finally, you can visualize, display, and share all your updated drone imagery and to make better timely decisions and with the latest images of the sites. So our current photogrammetry portfolio includes 4 products. I've already mentioned ArcGIS Pro, which is our premium desktop app and the access point for publishing imagery to the server and creating web services. The next one is AutoMaker, which is our web client for the enterprise image server. But today we're going to concentrate on the next 2. So Drone2Map, which is our standalone application for Windows. It does great 3D modeling, but it's only for desktop and it does not scale well to large projects. So Drone2Map is easy to use and is offered as the entry point for GIS users that are not imagery specialists. And finally, SiteScan, which is our software as a service cloud offering, which is applicable for flight planning, data collection, cloud processing, and analysis of drone imagery. So I will now hand it over to Geneviève to cover imagery management.
Thanks, Pierre. So as you've seen in the previous slide showing you the different products that can process drone imagery, within all these applications, you can not only process, but you can manage your imagery. Our imagery management capability is what differentiates us. It sets us apart. It's a powerful management tool and capability that allows user you to manage and host and stream massive imagery collection. It can be done rapidly and in a scalable way. It can start small or scale large depending on the size of your project. At the core of it are the following two data models. You have the mosaic dataset for imagery and raster data, and the last dataset for LiDAR data. These data models, they're essentially catalogs, they're like containers. They reference your source data along with their respective metadata. The tools work and scale both on desktop, enterprise, cloud infrastructure, Amazon and Azure cloud, and let you access that pixel information within the archive. And that's an important distinction to make. We're not talking about the pixel from one image file, but from all images within your entire archive. Visualization and processing can be applied to one image or all images on the fly, and as a web service if within an enterprise architecture with image server. This applies to numerous raster data types, including LiDAR and drone imagery. And with drone imagery, you can easily have hundreds of imagery in one single flight. Now, of course, prior to adding drone imagery to a mosaic dataset, you need to apply some photogrammetric processes to the raw imagery using a product such as Drone to Map for ArcGIS. This is our standalone PC solution for processing drone imagery. It's easy to use. It's a good entry point for GIS users that are not imagery specialists, as Pierre mentioned. As listed here, it allows you to transform imagery from drones into geospatial information products. It is targeted toward the single-use drone operators and sold via an annual subscription. And it's important to note it has limited scalability and the 3D processing can be quite intensive, so you'll need a robust PC. You can look at our help get started documentation to see what hardware specs are recommended. So with the application, you can generate 2D and 3D products, orthomosaics, terrain models, point clouds, 3D meshes. Shown at the bottom, you have smart inspection reports and 3D PDFs, as well as vegetation indices. This requires multispectral imagery with near and red edge bands. You can generate these products in the office or in the field, so you can check out a license to be in a disconnected environment. It provides an intuitive and automated user-friendly experience, including for batch processing, and supports a wide array of platforms and sensors. And when you're connected, you can easily publish and share products through the enterprise portal and ArcGIS Online. And you can also open your project in Pro if you want to do more analysis in just one click. All in all, it integrates seamlessly with the ArcGIS ecosystem. Now, last but not least, we have here now a demo that will show you. I used imagery collected over Qatar with a DJI Phantom 4 Pro PPK flown at an altitude of 90 meters. It has a GNSS PPK, which would increase accuracy. And let me share my screen. Here you have my project. So when you launch your application, you will be prompted to create a new project or to open an existing one. This is an existing one, but here are my recently opened projects that I could select from. In your new project, you're prompted to select a template. You can select a 2D rapid template if you want something quick. You're in the field and you want to just check whether you have proper coverage, your image you're calibrating. This will be quick because it produces results at a quarter of resolution for these types of outputs. For the 2D full, that's a high resolution product for these outputs. And then the 3D mapping will produce the 2D products on top of the 3D products. These are more specific to inspection and batch processing if you have multiple projects that you want to produce at once. If you go into the project, As you can see, you have an ArcGIS look and feel. You have the same ribbons. You have your table of content with your layers. You have your base maps, your map views, and a catalog pane here with your geo database that gets created by default. If you look at your project data, these get loaded by default. When you create your project, you will be loading your imagery. So it loads them into the map as a point file, as a point form. You can create each images, visualize them in image viewer, annotate them if you wish, and export these annotation. And you use these tools, these different tools for your annotations. They are geotag, which means that they have geolocation information within an EXIF header, or they sometimes are in a XML, XMP tag within, like, let's say, a TIFF file. Sometimes it's a separate file. If when you load your imagery, if the software doesn't find the geolocation of your images, it will prompt you to add a file. And you have the flight lines that get added by default. Your control point gets created by default, but it will be empty. In this case, I've loaded some ground control point, which are found here. I'll talk a little bit about that later. Map nodes are also loaded by default, and you would they're empty. You would create some annotations through an edit session. And now, if we look at your catalog, there's another product that does not get loaded and gets created by default. It's a mosaic data set. If you select a 2D or 3D products, it will create a dynamic orthomosaic with the boundary footprints and your images. You can just drag and drop if you want to add it. And for my project, I generated all of these products, and they are visual. You can visualize them here. I have an orthomosaic. This is a site in Qatar. It's a university construction site. We'll turn some things off. You can see there's some construction buildings, some materials, some debris. That's the 2D ortho. I also created some elevation models. I have a DSM and a DTM. For these products, I've extracted some statistics, very simple. I've extracted a profile on the DSM, which you can see here. I drew a profile line and it extracted the different elevation profiles within that from the west to the east. So you can see the buildings, and the spikes are the buildings and the trees. For this elevation profile, you can change the source to a DTM instead of DSM. It's up to you. It depends on what you want to do. Other analysis that can be done. Let's close this. You can also run some indices if you have the right band combination, but you can also, I've ran a volumetric analysis. It's in my result pane here. I renamed it the soil pile, and you can see the polygon I drew to capture the measurements of this pile of soil. And my measurements are all here: cut, fill, area, parameter. You can change the units in your mensuration options. And of course, for more in-depth analysis, you can open your project in ArcGIS Pro. Let's close a few of this. If we go back to our manage pane, if you select the template, it will select some of these by default. And if you want to fine tune, you would go to your options and you would fine tune within here. For example, you would select your contours. One important one is you would want to select what is the mesh resolution. I selected high, and other things like that. The format of your point cloud that you'd like to create. I use the SLPK package, but also a LAS format. And once you've selected which product you want, you fine tune your options, you just press start and it will generate your products. And last but not least, my 3D products. So the 3D products, I have a last point cloud file here and my 2D view. It is a last format, but I also have it as a SLPK package in point cloud format here. If you would like to change the renderer, this is an elevation renderer. You can change it to a class renderer. By default, Drone to Map will use 5 predefined classes: ground, low vegetation, high vegetation, building, and road surface. But you can also use an RGB, which is more realistic. And now the mesh. This is a 3D textured mesh, and it might take a while to refresh. But my imagery was mainly, it was all nadir, so it captured the rooftops, everything vertically quite well. The side of the buildings, I would have to capture some oblique imagery. The combination of both of them would produce a better quality mesh. It's taken a while to, we'll give it time to just show up properly. Still not finished, but we'll leave it there and then discuss our last option, which is sharing. If you would like to share the scene layer package, you would do so through your scene layer. You can share your ortho mosaic through a tile layer, and your DSM DTM through an elevation layer, and obviously you can use a web map to share your web package, your web content. Soon we will be able to use the imagery layer for your ortho mosaic. That's upcoming. It's on the roadmap for ArcGIS Online. And of course, you would have to be linked to your ArcGIS Online account or through a portal. Last thing I'd like to show you, just to do a bit of troubleshooting. If you'd like to look at your processing log, this is an history of the events that happened during the processing. It tells you the step-by-step task. Some warnings appear, so that can be very informative, and your processing report will give you, it basically allows you to do some quality assessment. It's going to have some summary information, your camera model, your grand sampling distance, some quality check, and there's some statistics and graphs. And at the end, you will have some initial processing details, but it basically tells you what were your processing options, your coordinate system, and your system information. And I think that is it for me. I'm going to start sharing this screen, and I will pass it back on to you, Brian.
Perfect. Thanks very much, Genevieve. That was great. I'm essentially going to do the exact same thing that Genevieve just did, but I'm going to talk specifically about SiteScan, which is our cloud offering. So it's a little bit different than Drone to Map, but has a lot of the same capabilities. So first thing I want to talk about before we really dive into SiteScan is a piece of SiteScan called the Flight Planning app. So this is an ability that was introduced with SiteScan to be able to plan your drone flights in the field. Now, obviously, it's going to work with the full suite of SiteScan products, so the cloud processing and everything, but it will also work with Drone to Map. So you can go to the Apple Store, and if you have an iPad, you can download it for free, and you'll be able to use it with Drone to Map. Alternatively, though, it can be used with the rest of the SiteScan suite. So this flight planning app is used to graphically select your area of interest on a map, and then you're able to go through and set some collection parameters like your flight pattern, your resolution, your look angles, and your image spacing. And the really nice thing about the app is it will automatically estimate your battery usage and the flight time, and this will all be based on your specific drone. So it gives you a good snapshot of, okay, this is the project I'm working on or the area I'm working on, how many batteries am I going to need, stuff like that. And if you are using the full SiteScan suite, so if you're going to process everything on the cloud, then the flight info is actually going to be shared directly with the cloud. So this is really great for fleet management. So if we have multiple drones, we can see who's flying and when, and the status of the batteries and all that sort of stuff. So that's really beneficial as well. So I just wanted to mention that flight planning app because it is useful as well for the drone to map users. All right. So with that, we'll jump forward here and we'll talk a bit more about SiteScan itself. So once your flight is complete, if you have used the SiteScan flight planning app, it can upload all that imagery automatically to the cloud and begin processing. Or, if you're using a different flight planning app, or, another common scenario is that somebody else is flying the drone and they're just providing the imagery to you, then that's no problem. You can just manually upload all that imagery up into SiteScan and process it there. And I'm actually going to show that in a few seconds here. So let's just step back a bit here and talk about SiteScan. So SiteScan is a web-based interface that we're going to upload imagery, and it's going to upload it specifically to the AWS cloud. And once the imagery is uploaded, we can set our project parameters, we can deal with ground control points, and most importantly, we can execute the photogrammetric process. So in contrast to drone to map, SiteScan is a complete end-to-end solution for your drone imaging projects. It provides fleet management, it's going to provide image processing, it has some analysis capabilities like drone to map, and it's doing all of this as a software as a service. And another key point to make here is that SiteScan is also connected in with the rest of the ArcGIS ecosystem in the form of either ArcGIS Online or ArcGIS Enterprise. So we'll advance here. So yeah, we could continue talking about SiteScan sort of in the abstract, but I thought it might be nice just to dive right into the product. I'll probably do a lot of the same workflows as Geneviève just did with drone to map, but we'll just see what the differences are with SiteScan. So I'll go ahead and share my screen. Here we go. Okay, so here we are. We're in SiteScan now. The most basic thing that we should point out before we say anything else is that we're in a web browser here. So I'm just logged into a Google Chrome session, and I've just, basically put my username and password in, and I've accessed SiteScan. And this is the home page, so it's given me an idea of all my projects and all the ones that I have. And you can see I've got some nice imagery from all over the world. So I thought to start here, what we do is we just go through the process of creating a project and uploading the imagery. So to do that, I jump into the all projects. So all projects are all the projects that everyone within my SiteScan organization has uploaded. So I'll go ahead and create a new project. I just need to give it a name. So in this case, I have some imagery over a military depot here in Ottawa that I was able to collect. Of course, I need to, doesn't look right, but that's fine. Just don't know how to spell anything, that's fine. And then we're just gonna provide it with a general location where we wanna put the project. We'll just put it in Ottawa. I could put in the actual address if I really wanted, but just for this, we're fine. Next. Now this is interesting. This is allowing me to share with other team members. So this is something we wouldn't get with drone to map, but we're able to, if I'm collaborating with several different people, I can select them, and then they're able to assist me with the project. They can view the project. They can make changes depending on the permission level that they have. In this case, it's just for me, so I'm going to skip this step. And just like that, I have my project created. So I can go through here and, add my flight plans, my GCPs, any supporting files I might need. But for me, really, the flight's already happened. So all I'm interested in is creating a new mission and uploading all that data. So let's create a new mission. We'll just call this my first flight. And we'll give it a time when we flew it. So what are we today? We're September 22nd, 2021. And we'll hit next. And then from there, we just go ahead and upload the photos. So just click this. You probably can't see this screen. That's fine. It's just open my file explorer. I'm just selecting all the images I have. And then it does what's called deduping, which has got to be the best word going. So that's just making sure there's no duplicate images. So it's looking through about 200 images right now. And then it will start actually uploading them to the cloud. And of course, if I wanted to, I could just automatically process them once the upload's complete. So there it goes. You can see it's starting its upload now of these photos. Now I'm just going to hit back. I don't need to upload them. I've already done that. We'll save everyone a little time. We'll just close out of that. So with the magic of the demo, I've already done that processing. So if we jump over here, this is the results. So if I just turn on my photos here, you can see these are the 219 photos that were uploaded, and we can click on any one of them just to pull it up, just to see a snapshot. So interesting with these photos is they're, like Genevieve's project, they're captured at nadir, so they're straight up and down. So not really good for 3D stuff, but I will show you what the outputs look like. So let's turn our photos off. So once the processing is done, we get basically the same products as what you would get in Drone to Map. So we get this lovely orthomosaic, and if we zoom right in, we can see we get this nice level of detail, which is great. And just to give you an idea, this was just flown with a DJI Mavic Air, which is just they don't even make it anymore, but it's just the drone I happen to own. So a fairly inexpensive consumer grade drone, and really amazing the level of quality that you can get out of it. So you get your orthomosaic, of course. Then you're going to get your elevation data. Again, it's going to be in either DSM or DTM. So you get both. It'll give a contour. It'll also produce an elevation model. So that's always useful. One thing that you don't get with Drone to Map is in this one, you'll get a cut and fill. Just give that a second. So a cut and fill is sort of specific, but it's very useful if you're trying to flatten an area. It will show you where the high points are and where the low points are. So if you were, for example, moving soil, it would show you where you would need to move your soil from. So just a little added piece. And then finally, you get a hill shade, which is always great to look at. They're very good if you're, doing some more cartographic stuff with your imagery when you're actually going to disseminate it. Turn that one off. And the last thing that it's just going to give you out of the box is this point cloud. So let's go look at that very quickly. So here we are. So this point cloud, you can see it's actually pretty good. It's going to be in the RGB color spectrum, which is the easiest to sort of understand for your eye. You can see though, I'm missing, for example, the sides of the building and stuff. And that's just purely because the imagery was captured, nadir. What I find really amazing though about this point cloud is even though my imagery was captured in nadir, it does a great job of actually creating a 3D surface for me. What I like about that is, we don't always get the best, the imagery has not always been collected for our specific purpose. It's not always maybe perfect, but we can bring that in, process it through SiteScan, and we'll still get a potentially very useful product at the end. Despite the imagery maybe not being quite perfect. So just wanted to point that out, if your imagery is, doesn't have an oblique to it, it can still do 3D quite well. All right, I think we're gonna leave this military depot. It's exciting, I suppose, but I have another project that a colleague of mine was actually able to process that's a little bit more dramatic and fun to look at. So we'll jump over here. So this is our quarry that's located in Switzerland. So obviously quarries are great for this sort of stuff because we get this huge elevation change and really good for 3D. And why I'm switching projects is this is an off nadir imagery that was used, and it also has some really good ground control points. So my military depot there didn't have any ground control points. Still put it very close to where it should belong on the planet, but it's not quite perfect. But when we have ground control points, of course, we can do a lot more with it. So just since we're speaking about ground control points, I'm actually going to show you just the process for how we work with ground control points in SiteScan. So I have them uploaded here, so I can turn those on, and it's going to identify on my orthomosaic here my different ground control points. And these are, we uploaded them, and then we can tag our photos manually. That's the process I'm going to show. But the interesting thing with SiteScan is if in the real world we were to use a checkerboard pattern like this, or we were to use spray paint and spray an orange X on our area of interest, SiteScan is actually able to do GCP detection automatically. So basically you feed it the GCP location and it will search through all the photos and find those and tag the photos automatically, which is really great. That saves a ton of time. You know, doing this GCP manually does take a bit of time. So, but that's no worries. Not everyone's going to use that. For example, if we zoom in here, you can see the imagery I'm using actually has this yellowish triangle that they used as their GCP point. So we would have to manually do this. So all I would do is just hit my review GCPs. And then it's just going to give me an idea. So we can see I've already tagged 5 GCPs or 5 photos per GCP. So I can come in here and select this GCP, for example. Just give it a second. And the nice thing is SiteScan goes through for me and it identifies all the photos that it thinks should be where that GCP will be visible. So this really saves me a ton of time. I don't have to go click on a bunch of photos that, you know, oh, maybe the GCP's in there. No, SiteScan does a pretty good job of figuring out for me which photos are relevant. So I can see that this one's blue, so it's relevant. So I can click on that. And it even points out the general area where it believes the GCP should be located. So I could then just zoom in, find my little yellow triangle, select that, and then I go ahead and save. And that would save the GCP ready to go for each of those. So that photo would be tagged with that GCP, which is super useful. So our sort of rule of thumb for most of these, especially when we're talking 3D, is to have at least 5 GCPs per project, and then to have 5 photos associated with each GCP is a good rule of thumb. You know, you can do less or you can do a lot more depending on the level of accuracy you're interested in. So once I was done doing all that GCP tagging, I'd just be able to reprocess my project and I would get a more accurate version. So that's really great. Okay, with that, let's move to another piece. Another reason why I moved to this mine or this quarry is because it was captured off nadir like this, it produced a really good mesh. So just like Drone to Map, it produces a mesh for me. It's in the processing settings. I can turn that on and off depending on what I'm looking to get. So here's our mesh here. And I really like this. This is just so dramatic, being right into the hillside like this. Really cool area. And this mesh is great. It uses the Shure engine, and it does a really good job of processing this mesh. So if we actually zoom in, we'll just give it a second here to catch up. It should be a little quicker than Drone to Map, and that's again just because of the cloud. So we're just loading this all in the cloud, so it's a little faster than on the desktop, which is really beneficial. So I really love this mesh. We can see all the heavy equipment that's being used, and we get a nice visual for everything. So those are sort of the products that come out. Now we also have a whole series of analysis tools that come with. So you know, if we go back to our point cloud here. You know, we can do that elevation profile tool. So I've actually already run, so we turn that on. You can see I can get an elevation profile of the quarry, just like we did in Drone to Map. One added benefit, though, is we can actually increase our line width of that profile, and it will actually capture a wider swath of our area of interest, which is cool. And then we're able to interactively grab pixels out of each area. So that's a cool tool. There's also a whole bunch of measurement tools that are available. So we can measure area and we can measure heights and angles and all that. I'm not going to get into all of those right now. I just want to point them out. We'll jump back here to the 2D though. One tool I definitely want to show, just because we showed it in Drone to Map, is the volume tool. So we can easily do volumetrics. So we could do the whole quarry, for example, but probably more interesting in this case is to do, like Genevieve did a sort of soil pile. In this case, it looks like they're doing some sort of tire recycling in this area. So maybe we just want to find out, you know, what's the volume of tires that are sitting here. So to do that, it's quite simple. We come here, we turn on the volume tool. We go ahead and just grab the area that we're interested in. Of course, we can make this as straightforward, as complex as we need, double click to end. And just like that, it's calculated the volume for me. So it's going to create a volume report PDF that I can then send to people in the field if I need. And I can come in here and more specifically view and edit the volume. So you can see it's roughly 1,400 cubic meters. If we go and edit the volume, though, we can change some parameters around to get a really better sense. So, so here we are here. Here's our volume. We can see we have a little bit of a rise, though, in our DSM underneath, which maybe isn't accurate because this is, we probably would think that this is on maybe a concrete slab or something. So the nice thing is we can change the plane that's being used to measure. So we can change that to a level plane and that will regenerate. And we see it's made quite a big difference. We're now at 2,000 cubic meters. So changing that plane is very useful. The other interesting thing is we can actually use a previous mission. So if we're flying over the same area maybe once a week, and that pile is always changing, we can use the previous week's surface, and then we'll be able to tell, okay, there's this much more, there's this much less tire or soil or whatever it happens to be in the area. If we don't have another mission, we can use a custom surface to do the same sort of analysis as well. So lots of different options for doing this volumetric analysis. And I just really like, I love this. I just love how interactive it is and how it pans out. So that's great. And then, okay, now the last thing I think we're going to show in this pane anyways is we want to jump back to, well, let's jump back to the mesh because it's more interesting to look at. But we have a whole bunch of options here for sharing out our data. So down here, we have our process button and we can add data to the project, but we can also export our data. So this would be equivalent to the share button that we saw in Drone to Map. So if I open that, you can see I can share out my orthomosaic, my contours, point clouds, all of that. Photos as well. This is important, I think, to note is SiteScan has unlimited cloud storage for photos. There is, once you have SiteScan, you can put as many photos up there as you'd like. So the nice thing is once I'm done my flight, I can upload all the photos to SiteScan, do my processing, and I can delete all those photos from my hard drive. I no longer need them. And if for whatever reason I need to get access to those photos again, it's very easy to just come in here and download them on a per project basis. So that's a great management tool. So that's sort of the old school way of sharing stuff with the export. The better way, though, is to actually share directly to ArcGIS. So with this button, we can launch this, and we can share either to ArcGIS Online or we can share to ArcGIS Enterprise. So I'm just going to share to ArcGIS Online. So I'll sign into my account, my ArcGIS Online account, that is, and then I can just go ahead and select all my products here, and I can publish them. And those will then publish them all out to ArcGIS Online, and then I can disseminate that, put them in a story map, put it in a dashboard. I can even put it in a mobile map so that people can view it on their mobile device out in the field. That orthomosaic could be beneficial to people out in the field, for example. And then the last thing I want to show before we jump back to the slides is that SiteScan has a whole fleet management piece. So we can see here it's got a nice dashboard that shows us, how many flights have occurred in the last little while, what the activity is, how many pilots, aircrafts, batteries, all that we've used. Speaking of that, we can come into the actual aircrafts and see, for our organization, what aircrafts we have. We can put in their purchase dates. If there's, if they need certain licenses and stuff, when do those expire? So really good, especially when we're talking about multiple drones here. This is really important to keep everything in order. And not also just for the servicing of the drones, depending on the amount of flights. And we get the same sort of view for each battery as well. So we can, tell, if a battery's done so many flights, then maybe it's time to replace it, stuff like that. And then finally, in the organization settings, I like this pane because we get a nice snapshot of basically how much space I'm saving on my hard drive. So there's currently 128 gigabytes that's just living in the cloud, and I could just keep putting more and more up there to my heart's content and save all that space on my hard drive. Okay, so that's basically SiteScan in a quick nutshell. So I'm going to stop and we'll jump back to our slides here. So if we move on here, so one thing I did want to mention is that SiteScan is really supports the TCPED workflow. So TCPED, for those who haven't heard of that before, has been used within the imagery intelligence community for many years. And it's an end-to-end workflow that starts with tasking of various sensors, collecting the imagery, all the way to disseminating the final information products. So specifically when we're talking about SiteScan, I mean, initially for our tasking and collecting, we're going to be talking about the SiteScan flight planning app. And then for our processing and exploitation, we're going to talk about, the SiteScan cloud. And then finally, for more advanced exploitation as well as dissemination, we're going to be talking about ArcGIS Online and ArcGIS Enterprise, so the ability to share it out from there. Okay, so Pierre has talked a little bit, given you a little teaser about the drone collections. So as you've seen, there's multiple different tools that we have for working with drone imagery. So what we've done is we've just packaged them up into these drone collections. And it's just a way of helping people understand and helping people get the actual software they need depending on what they're trying to accomplish. So I'm just going to run through them very quickly. So we have our drone mapping collection. So this is ideal for your standalone drone operator. So they want to capture their data autonomously using the SiteScan flight planning app. They then want to process on a local desktop. So they'd be using drone to map here. And then they're going to disseminate all that information using ArcGIS Online. So that's sort of the most basic end-to-end workflow. From there, we would bump up to the drone mapping and analysis collection. So that's the same as the previous. All we're going to do, though, is add additional analysis capabilities in the form of ArcGIS Pro with an image analyst extension. And then from there, we now jump up more into and you can see there's more drones here. We jump up into the online drone mapping collection. So this is going to use a pure cloud-based solution. So again, we're going to use SiteScan flight planning. We're going to use SiteScan for processing and managing, and then we're going to disseminate with ArcGIS Online. The really nice thing about this cloud offering is it's completely scalable. We can have as many drones and drone operators as we need, and we can share it out with the whole organization all through the cloud. And then finally, we bump up to the big guy, the big enterprise drone mapping and analysis collection. So again, we're going to rely on SiteScan for the collection and the processing, but then we're going to really leverage the big horsepower that comes with ArcGIS Enterprise and ArcGIS Image Server. So we're going to use those for more heavyweight analysis, and we're also going to use it for our dissemination as well. We're also going to throw in there the ArcGIS Pro and with an image analyst, just so our individual users can do some processing on their own. Okay, just a quick recap here. So in summary, SiteScan provides dynamic elastic processing. So it leverages distributed processing in the cloud that automatically adds more computation power based on workload. So essentially, that's just a fancy way of saying that we can process as many different projects as we want all simultaneously, and it will have no performance impact whatsoever. So, if we're processing 10, 20, 30 projects all at once, no problem. They just spin up more Amazon servers to handle all that load. So that's quite different than how a drone to map would work, for example. And then as an end-to-end turnkey workflow, here we're talking about really the SiteScan flight planning app with the SiteScan processing capabilities tied in with ArcGIS Online or ArcGIS Enterprise. So it really runs the full gamut and leverages all the Esri tools that you might already own. So really that together forms a complete imagery platform solution that really can drive your business forward. So with that, I'm going to pass it back to Pierre to give us some more resources.
Thank you, Brian. So you can see here, Esri provides many online resources for learning more about imagery workflows and products like you saw today, like Drone to Map and SiteScan. We also have training and lesson plans that's focused on a specific application. So all these resources can be used as a guide for your own work, and we will share these links with you in an email following the webinar. Esri Canada also conducts online fee-based imagery training. So we have these two courses you see here, one for imagery analysis using ArcGIS Pro It's a 2-day course using version 10.8. And we have a second course, Introduction to Drone to Map. It's a 1-day course using version 10.5. And you learn how to do what Geneviève showed you today, how to create these products. You can also go to learn.esri.ca to search our course catalog for the right course for you. So as you saw today, ArcGIS can process drone images in many ways and create many types of products for visualization and further analysis. So Drone to Map is our standalone app for desktop. It can quickly and easily turn drone imagery into 2D products, also work in a disconnected mode. With SiteScan, you can leverage the processing capabilities of cloud computing, cloud storage to process, store, or share your drone imagery quickly across your organization. So in summary, ArcGIS offers a complete system that integrates your drone with ArcGIS Online and other ArcGIS Enterprise capabilities that you have, and it can transform your drone imagery into accurate information and timely intelligence. So at this time, we're going to stop our presentation and we're going to answer some of the questions that came in. So the first question that I see here, and I'm going to ask if Brian is, have you used these drone tools to create augmented reality products?
I have done it before, yeah. So we basically publish, when I showed the export there, there's an ability to export your mesh out as a scene layer package, and depending on the engine you used, you can export it to a variety of different formats. And then once you've exported that out, you can then ingest it into your AR solution. So whether that's, Unreal Engine, like the Dutch Army, City Engine, stuff like that, there's a few different products. So really, SiteScan sort of generates the mesh, and then you just put it into whatever AR technology that you want from there, as long as it supports that format.
Thank you, Brian. The next question I think Geneviève, maybe you can address is, do we need to specify the geoid height above the imagery ellipsoid difference for the output coordinate system?
Not necessarily. You find when you use Drone to Map, it's built on top of Pix4D, so a lot of the settings are the same. So yes, you can specify your geoid, but you can also just input your GCPs, and the GCPs will do the correction, and your product will end up in the right. Because sometimes if you don't have the GCPs, you see that your product is underground or above ground, and then you add your GCPs and it will make the correction. But if you do want to do it manually, yes, there is an option that you can do that. It would be in your coordinate system. You can put a geoid height.
Okay, thank you. The next question was for Brian. It says, how long did it take you, Brian, to fly your drone pattern using the demo today?
Sure, yeah. So the military depot, that one I actually flew, and that one took only about 10 minutes. When we're doing those nadir patterns, they're much faster because we just go up and down. We don't have to do what's called a crosshatch. In terms of that quarry, that was a big site, and they used a larger drone, and I think it used 2 or 3 batteries. And of course, when you're flying those off nadir ones and you do the crosshatch pattern, you're probably 80% longer time in the air because you're basically covering the same area twice. So yeah, that's just something to consider.
The next question I'm going to ask Geneviève there. Does Drone to Map work with only a specific type of drones, or is it generic?
It's generic. You'll need certain things in your imagery. They'll need to be geotagged. So if you have, it will take JPEGs and it will take TIFF, but as long as you're geotags, there need to be some location information, and you also need some camera parameters in there, focal length and some other ones. If you have all these, the software will find these within an XFeather or within the XML, XMP tags, and it will place your imagery correctly in space.
Thank you. The next one for Brian is reference side scan, the editing of DTM and DSM. Is the manual ground editing, how is the manual ground editing accomplished? Is there a tool allowing to manually edit the elevation of the ground?
Yeah, so there's a few points here. So of course our ground control points are our best friend in this sense. So if we want to make sure that our terrain model is actually on the real ground, then a ground control point's really the easiest and best way to go about that. Now, of course, sometimes our, for example, the mesh in that mine was a little too high. So there's actually right there in SiteScan, you can actually lower the mesh down. So I brought it down, I think, by 50 meters or so, which was quite significant. So you're able to actually bring it down if you need. Now, as opposed to, there's no tool though for actually editing individual pieces of the digital terrain or surface model. We can only edit basically the whole piece. So yeah, we would bring it into, Pro and be able to, edit either the point cloud or edit the actual surface model itself in Pro. And I know I see on the question there that's Pro Advanced and is the image analyst extension required? I think for most of it, you should be fine with Pro Advanced, but yeah, the terrain modeling stuff, usually you require either a spatial or an image analyst extension for stuff like that.
Okay.
As far as I'm aware.
Thank you, Brian. The next question is about the average price for both drone to map and side scan, just to get an idea. So for the drone to map, for a 1-year subscription, it's $2,500 for one name user. And for side scan, so it starts at, for one user, it's about $9,000 per year, but then it goes down as low as $5,000 if you have 10 plus users. So I recommend you contact your local ArcGIS Canada office or your account manager to discuss these pricing.
And one thing I'll just throw in there, Pierre, is that $9,000 is basically for a full-blown license for somebody who's going to be flying the drones, doing the processing, all of that. There are some cheaper licensing available for people who maybe aren't flying the drones, so they're not pilots, or if they just need to come in and view the data within SiteScan itself. Now, they can also just view the data in ArcGIS Online, but if they need to be in SiteScan, there's also a view license. So, but yeah, if that's of interest to anyone out there, reach out to us and we can go through your particular business need.
We have time for a couple more questions. I'll answer the last one here. Are we going to get a copy of the slides? Yes, you will have a PDF version of the slides and a link to the recording, and the PDF will have the links which are activated so you can go look at the story maps or the resources. And one more question. Brian mentioned this free version of SiteScan flight planning. So what does it do and how do I get this?
Yeah, so basically it gives you almost all the functionality I just mentioned. The SiteScan flight planning app only works with an Apple iPad. So you will have to have that, and then you'll go to the App Store, you'll be able to see it there and you'll download it. So when working with Drone to Map, that's exactly what you would do, but the free version essentially just doesn't connect directly to the SiteScan cloud. So the ability to upload information about the flight and the battery and the aircraft and all that, as well as upload the imagery automatically, that's sort of reserved for obviously once you have a full-blown SiteScan license. So that's the only difference.
And the only comment I want to add is we also have the evaluation copy of the software. So I encourage you to contact your local account manager or ArcGIS Canada office to request, for example, a 30-day evaluation copy of Drone to Map as an example. So in closing, I just want to thank you for participating into this webinar today. We also want to get your feedback, so please take some time to fill out the survey that comes up after you log out. And this ends our webinar for today. You have our email addresses here, so you can reach out to us if you have more questions. So this will end our webinar, and thank you for participating today.